Hey guys, in this video we're going to do a little bit of an introduction to rational functions. So just reviewing what our two parent rational functions look like. So here we are looking at our first parent rational function. It is the function 1 over x, and this is what the graph looks like. We've talked about this extensively in class at this point, but rational functions are really defined by their asymptotes. So you'll notice that in this vertical line here, the y-axis, and this horizontal line here, the x-axis, the function does not cross those two lines. And so those are what we call asymptotes. And asymptotes are just lines that our function approaches, but it doesn't actually touch. Why do these asymptotes exist? Well, if I look at my function, I'm going to have a place in my function that is not defined. So if I were to try to plug in an x value of 0 into this function, I would be left with 1 over 0. Right? I can't divide by 0. This does not equal a number. It is undefined. So I cannot plug in 0 to my function. That is this domain restriction where I could plug in any other x value. I can plug in big negative values over here. I can plug in positive values over here. I can't plug 0 into my function. That is why there is no place on the y-axis that my function exists. So there's no y-intercept here. Now, why does this approach the asymptotes like this? Well, I have to think about the actual function 1 over x and think about how that is going to function when I plug in different values. Let's say I were to plug in -4 into this. Well, if I plugged in -4, I would have 1 over -4, or in other words, -1/4. So my y value, it's a little tiny -1/4. It's like right here. Well, what if I plug in the value -1? Well, if I plugged in -1, I would have 1 over -1. That would give me a y value of -1. So I'd have this point on the function. But what if I plugged in -1/2 or -1/4? Well, when you divide by a fraction, dividing by a fraction is the same as multiplying by the reciprocal of that fraction. So I'm going to actually rewrite that as 1 times -2 over 1. And you'll see how that would come out to -2. So when I'm at an x value of -1/2, my y value is down here at -2. And that keeps going. So when the denominator is a bigger number, or like a further negative number, then the fraction is going to have a smaller value. But when x gets really close to 0, it's a fraction. It's like 1/5, 1/10, 1/100th, or it could be written as a decimal, 0.01, 0.02, 0.00001. That actually makes the value of my function way more extreme. So if it's a positive x I'm putting in, it's going to be a really big y. If it's a negative x I'm putting in, it would be a really small y. So it would be way down here. And that's where it gets the shape of the function. Okay. Once you know the shape of the function, though, we should be able to draw in these asymptotes, these lines that my function never crosses. If you're ever trying to draw in the asymptote, what you're just going to do is you're going to see, well, what line is my function approaching on the right and left? You see how it almost lines up with the x-axis? It's right below that right here, and it's right above that over here. So I know that that x-axis is my asymptote. And I'm also going to go ahead and write in the equation for this here. So the equation for that is the line y equals 0. Again, this is something we discussed extensively in class, but a horizontal line will always have the equation y equals some number. That is because as I move left and right along this line, my y value will always be 0 because y only changes when you go up and down. So if I cross the y-axis at 0 and my line is horizontal from there, then at any point on this line, x is changing. X goes 1, 2, 3, 4, 5. But y stays the same. Y is equal to 0. The opposite is true for this vertical asymptote. I drew it the same way where I just looked for what vertical line my function was approaching and it was getting really close to the x-axis. So I drew a dotted line here to represent my vertical asymptote. And the equation of that line is that x is equal to 0. And again, that is true because this line, it crosses through my x-axis where x is 0. And as you go up and down, your x value does not change. X only changes going right to left. So my x is the same for any point on this line. Now my y changes, right? As I go up this line, 1, 2, 3, 4, 5, I go down negative 1, 2, 3, 4, 5. I can't define this line by y because it has an infinite number of y values, but it only has one x value, and that is that x is always 0. So that is how we describe this asymptote. Okay. So what you need to take away from this is knowing what the function f of x equals 1 over x looks like, and knowing what the asymptotes are. So you know that it has a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. And then you know the function is essentially these curves that approach those asymptotes in both this first quadrant and down in this third quadrant of the graph. So now let's look at a different function. This is the other parent function for rational functions. Let's look at g of x equals 1 over x squared. Okay? It doesn't matter if this is g of x or f of x, whatever you name it is fine, but we're really looking at 1 over x squared. Okay, so basically y equals 1 over x squared. And you'll notice that this graph, it almost has a similar shape in the first quadrant, but it has the other curve happening here in the second quadrant instead of the third quadrant. So why is that happening? Well, when I plug in positive values of x, I'm going to get positive values of y, right? Let's say I plug in 1 for x, that would be 1 over 1 squared. That would give me a y value of 1. Let's say I plug in 2. That would give me 1 over 2 squared, which gives me 1 over 4, which is why you can see that when x is 2, y is about a fourth. But what's going to happen on the other side of my graph? Well, if I plug in negative 1, let's see what happens. 1 over negative 1 squared. Well, squaring a number is the same as multiplying it times itself. So that is saying the same as 1 over negative 1 times negative 1. And when I multiply a negative times itself, a negative times a negative gives me a positive. So that actually comes out to 1 over 1, or in other words, positive 1, just like it did when I plugged positive 1 in. So because you are squaring the x value, and when you square a number, the negative will always go away, we're going to have symmetry across that y-axis here, and you're going to have the same y values on either side of this function, either on the right or left side of the y-axis. So when x is 1 or negative 1, y is 1. When x is 2 or negative 2, y would be 1/4. And again, we can practice that and show it here. That if I'm squaring negative 2, well, negative 2 times negative 2 is positive 4, so I see that come out as a positive. So that is why this graph looks slightly different. You may also notice that it gets a little bit closer to the x-axis a bit faster, and that's because I'm squaring this number, so it does approach it quicker, but it follows the same shape overall, because it's the same thing where as the x value gets bigger, the y will get smaller, and as the x gets smaller, the y will get bigger. Hence why we call this that inverse variation, right? The x and the y, they do the opposite thing of each other. So now that we know why the graph looks like this, and we know that it looks like this, let's move on to talking about the asymptotes. So I want to draw in both the horizontal and vertical asymptotes. Again, the asymptote is a line that this function approaches but never crosses. So if you see the function over here on the left side and on the right side, it's getting really close to that x-axis. Now I know it doesn't quite touch that x-axis because no matter what x value I plug in, this fraction will never quite become 0 because the numerator is not 0. The numerator is 1. But it could be a really, really small number, like 1 over 100,000, right? So it's going to get really close to the x-axis. And so when I see it get really close to the x-axis, I'm going to come in here and I'm going to go ahead and draw that asymptote along the x-axis. And again, we always just draw asymptotes as dotted lines. And since my horizontal asymptote has a consistent y value of 0, right? At any point on that line, the y value is 0. So the equation of that line is y equals 0. Again, I know it's the opposite of what sometimes you might intuitively think because you're like, if the x-axis is horizontal, so a horizontal line should be x equals. But because the x-axis is the horizontal axis, that is why as you move right to left, x always changes. So you can't define the line by its x value. You have to define it by its y value, which is the part that doesn't change. And then now that we have that asymptote, we have this vertical asymptote. Again, on both sides of the y-axis, you see the function sort of approaching it. It's right in between. So I am going to go ahead and draw in another dotted line, this time vertically, along the y-axis. And that is the equation x equals 0, because again, it is a vertical line, so it's always going to be x equals some number, and the x value on this line is 0. So what is the takeaway here? You should know where the asymptotes are. So for both parent functions, the asymptotes are y equals 0 and x equals 0. But for the other parent function, 1 over x, you saw the function up in the first quadrant and the third quadrant. Well, here you're going to see my curves in the first quadrant and the second quadrant.